Sorry about that. The camera battery died, and so I had to plug it back into the charger. But we were talking about the formula to figure out the future value. And we were saying that the amount or the future value is the principal times 1 plus the interest rate for that period to the number of periods degree. So what we could do is, since we have our quarterly rate, which is divided by 4, so our rate per period is going to be 2%, and 1 year times 4 periods is equal to 4. So we're going to do 1.02 to the fourth is equal to 1.02 to the fourth. 1.0824 times 500 is equal to our $541.22. So one of the ways that the banks tell you is in the nominal rate, 8%, or for this example, this problem, the interest rate was 8%. But their annual percentage yield is actually the interest, so $41.22 divided by the principal, 500. So if we actually do that, 41.22 divided by 500, the APY of this isn't 8%, it's 8.24%. So that's what the difference between the nominal or the stated rate is compared to the annual percentage yield. So let's do practice problem number 4 of the quiz. And it says, if the principal is $8,000, interest rate of 6%, and compounded quarterly, what is the APY? So 8,000, we got 6%, and it's quarterly, so it's 1/4. So what we're going to do is 6% divided by 4, so our percent is going to be 1.5%, and our periods is equal to 4 times, how many years did it say? And since we're doing it for the APY, we don't need number of years because it's 1 year, so it's 4 periods. So there's a couple ways that we could calculate the interest, because we have to figure out how much interest is made before we can figure out the APY. So I can either go in my calculator 1.015 to the fourth times 8,000, so 1.015 to the fourth is 1.061364 times 8,000 equals, so $8,490.91. So minus our 8,000, interest is $490.91 divided by 8,000 gives us our APY of 6.136%. So it said it was 6%, but it's actually 6.136 or 6.14% is the APY. Now it said if you do it instead of quarterly or semi-annually, if you do it daily, they actually give you another table, which I recommend printing off. So when it says compounded daily, or look at table 12.1, you actually know what they're talking about. So we can do number 5, and I want to use the chart from table 2.1, and it says $1,800 for 5 years at 6% daily. So I'm going to look at my table, and it shows that at 6%, and 5 years daily is 1.3498 times 5, or times how much thousand? 5,000. The practice problem is 1,800. That would have been a different number. 1,800 equals. So if we had a daily compound rate for 5 years of 6%, we would get $2,429.64. So that's how you do that. Now what happens if we know how much we want to have in the future? How much do we invest now? And that's actually called the present value. What do we need now to be able to have an amount in the future? So if we want $1 in the future, what do we need to put in today? And so you can either use the table, 12.3, or you can use a formula. The present value formula is the amount divided by 1 plus the interest rate to the number of periods degree. So we're going to look at the practice problem quiz to get some experience, and I think that's the best way normally to figure out what's going on. So I'm actually now at page 304, and we're just going to do numbers 1, 2, 3, and 4 if we've got battery on the camera. So it says the future amount desired is $9,000. So in the future I want $9,000. I'm going to wait 7 years, so my time is 7 years. And it says my rate is 5.5% semi-annual. So 5.5% semi, which means it's going to be divided by 2. So my period time is going to be 14 periods. My interest is going to be 0.25% because I divide by 2. So I can do this a couple ways. I can plug it into the formula. So I can have 9,000 divided by 1.025 to the 14th. And I can do it that, and that should get it to me, or I can use the table if there's a 2.5%. So 1.025 to the 14th times 9,000, or divided by 9,000. So I need $6,369.54 today to get $9,000 in 7 years at 5% semi-annually. So number 2 wants $20,000, 20 years, 4% annually. So 4 periods, 4% every year. So we can just do this into the formula, 20,000 divided by 1.04 to the 20th, because it's 20 years annually. So 1.04 to the 20th. Now that's my compound value, if I look it up on my table, is 0.4563, so I can either multiply that by 20,000, or I can times this and divide that by 20,000. So I get, let me see, 9,127 and 74 cents. So if I want $20,000 in 20 years, maybe for college, for the kids, even though I don't have kids, I'd need to invest $9,000 today. Now, for example, Bill, number 3, needs $40,000 6 years from today to attend VPR Tech School. How much must Bill put in the bank if he gets 8% quarterly to reach his goal? So he needs $40,000. So 40,000 is what he needs. He wants 8%, or he gets 8% in 6 years. So quarterly, I'm going to have 24 periods, and I'm going to have 2% per period. So 1.02 to the 24th, so 40,000 divided by 1.024 to the 24th gets me he needs $24,000 today, $868.86. Now you can either do that 2 ways. Again, you could just take 24 and 2%, look it up in your table 12.3, and multiply that by 40, or you can use a formula. So there's 2 ways that you can do all of those problems, either the future value or the present value. So if you have any questions, feel free to email. I look forward to chatting with you on Chapter 13. Thanks. Take care.